Good morning everyone. Today we are going to learn about an existing topic in virtualization technology called GPU virtualization. Traditionally, GPU or graphics processing unit were mainly used for graphics rendering and gaming. But today, GPU plays a major role in artificial intelligence, machine learning, scientific simulations, cloud gaming, healthcare, imaging, and many other computationally intensive applications. The major challenge is that GPU are expensive resources. Not every user or organization can afford dedicated high performance GPU for every task. This is where GPU virtualization becomes important. GPU virtualization allows multiple virtual machines or users to share a single physical GPU efficiently while maintaining good performance and resource utilization. So in this lecture we will discuss about the need of GPU virtualization, its architecture and different virtualization methods, benefits and applications. So let's think about it, like imagine a situation where multiple users can simultaneously use a single powerful GPU for different locations. From different locations they are using a single powerful GPU. So for example, one user trains an AI model, another user plays cloud-based game, and third user performs medical image processing. So all these users can share the same physical GPU without purchasing separate hardware. So this idea transformed industries by reducing cost, improving accessibility, and maximizing hardware utilization. So this concept is called GPU virtualization. So let us understand the GPU need, why the GPU computing needs. So before understanding GPU virtualization, we must understand why GPUs are important. GPUs are designed for parallel processing. Unlike GPUs can process thousands of operations simultaneously. So major user needs include high performance parallel processing, that is applications like AI training and 3D rendering requires massive computational power. So cost effective GPU access. High-end GPUs are costly. Virtualization helps share resources economically. So multi-user resource requirement. When it comes to multi-user requirement, the organization requires many users to access GPU resources at the same time. So resource sharing without compromise, even while sharing, user expect performance isolation and smooth execution. So let us consider the real world application, that GPU virtualization is widely used in real world application. AI and machine learning, deep learning training requires huge GPU processing capacity, like virtual desktop infrastructure. Employees can remotely access GPU-enabled desktops from anywhere. In cloud gaming, games are rendered on cloud GPUs and streamed to users online. Likewise, in healthcare, medical imaging system uses GPU for MRI and CT scan processing. These applications demand scalable and efficient GPU processing. So, current user challenges, that although GPUs are powerful, user faces several challenges like high GPU hardware cost. Modern GPUs are expensive and increase infrastructure cost. Underutilization. Many GPUs remain idle during low workloads, wasting resources. And the next is limited resource access, that is traditional GPU systems are location dependent. And complex resource management, that is managing GPU allocation manually is difficult in large environments. So GPU virtualization solves these issues by improving sharing and automation. So GPU sharing challenge. The main challenge is how can one GPU be efficiently shared among multiple users without performance degradation. So the system must ensure performance maintenance, efficient allocation and cost optimization. So the virtualization layer should dynamically distribute GPU resources based on workload demand. So what is GPU virtualization? So GPU virtualization is the process of dividing a physical GPU into multiple virtual GPU instances. Each virtual machine feels as if it has its own dedicated GPU. So the key features include multiple users share resources, that is several users can simultaneously access GPU resources. Efficient resource allocation, that is GPU power is dynamically distributed according to workload needs. Network accessibility, that is virtual GPUs are accessed remotely through the network. So this increases scalability and flexibility in cloud environment. So GPU virtualization methods, there are four major GPU virtualization methods. The first is pass-through. In this method, an entire GPU is assigned to one virtual machine. So the advantage is near native performance and high efficiency. When it comes to advantage, there is also a disadvantage that it cannot be shared. Mediate pass-through. is the second method. The GPU shared among multiple virtual machines using a hypervisor. So the advantage is better resource utilization and multi-user support. And the third is GPU emulation. The GPU simulator virtually in software. So it is flexible development deployment advantage, but low performance compared to hardware-based methods. The fourth is nothing but API level remoting. That is GPU API all calls are intercepted and redirected remotely. So it is easy to implement, whereas the disadvantage is medium performance and higher latency. So different methods are selected depending on performance requirements and budget. So when it comes to benefits of GPU virtualization, GPU virtualization provides several benefits like cost efficiency, scalability, remote access, improved utilization. So the performance optimization, to achieve better performance, optimization strategies are necessary. So memory bandwidth optimization, reduced delay in data transfer, workload scheduling, that is efficiently allocates GPU processing time, GPU monitoring, that is tracks utilization and performance metrics.